Data flows like water, and DTS is the pipeline. Watch how Serverless make migration and things invisible. Hi, I'm Xizini from Alibaba Cloud database team. Today, we will talk about build seamless data workflow with serverless data transmission service. Today's session will split into three parts. First, I will give you a quick overview of DTS to help you better understand our background. Data Transmission Service, DTS, is a high-performance cloud service that provides data migration, data real-time subscription, and real data synchronization. DTS supports over 20 database types, including relational database like PolDB, NoSQL like Tear and Redis, and analytic database like AnalyticDB. And you can use our Java, Python, Golang SDKs to build your own application that receive real-time updates whenever the data change in your source database. We are committed to deliver high performance, high availability, and user-friendly cloud service. At the heart of DTS is our any-to-any architecture, which gives you the flexibility to migrate or sync data from different data types of database, like migrate data from MySQL to PostgreSQL. Trusted by our customers, DTS has already done over 1 million migration with zero downtime. In 2024, we sent Serverless DTS to GA. With the help of serverless scaling, DTS now delivers a more cost-effective solution, freeing our customers from the heavy lifting managing data pipelines and let them do what matters most. In this session, we will dive into serverless DTS. And we simply break down serverless DTS into 4 steps. First, in the collections phase, we collect metrics like CPU, memory every second, and we use those metrics and the historical data. Well, we will decide whether to trigger scaling or not. If scaling triggered, DTS will scale DTS with zero interruption. After scaling, we will compare the metrics before and after the change. If the scaling doesn't improve any performance as expected, we will automatically roll back right away to ensure stability. And as shown on the right, the serverless DTS architecture handles all the local scaling operation within each DTS node. The eigen agent will gather the metrics from the DTS instance in the real time and decide whether trigger or not. If triggered, it will scale the DTS instance in local and without any interruption, and send a scaling event for the persistence and for the building. If the DTS node is out of resource, DTS scheduler will do the remote scaling and transfer this DTS instance from this node to another. This distributed design allows DTS to remain resilient even if the centralized control panel failures, which I think is the critical capability for any serverless systems. With the help of DTS schedule algorithm, 99% of the scaling operation occurs locally, and both scale up and down will complete within 1 second. Service building service will filter all unnecessary scaling events before scaling to save costs, which means if the scaling doesn't improve any performance as expected, DTS will mark this scale-up failure and ignore the scaling event for building. Therefore, the building DU, the origin line shown on the figure, will lower than the allocated DU, the blue line, if the scale-up mark failures. This will ensure our customer will not charge more if the scale-up failure and the scale-up doesn't improve any performance. And the figure on the top is the real-world performance using serverless DTS. The blue line is a data change count in a typical online system. And we can see that the workload is higher on the work time and lower nearly to 0 in the night. And the RPS varies from 0 to 12 thousandths. And the system has a batch job in 5 a.m., which is a classic scenario in an online system. The origin line is the serverless DTS RPS limit. We can see that it scales up and down with the online workload and maintain very low latency. Even if the workloads increase from 0 to thousands in a very short time, the latency only reach 12 seconds. Compare serverless DTS with other serverless products. Serverless DTS are more faster and less cost. In the next session, we will get hand dirty, try to build a data workflow using serverless DTS. We will build a data workflow that connects ProDB to AnalyticDB. To simulate the real-world traffic, we will use Sysbench to generate a workload on the ProDB, and the serverless DTS will seamlessly sync data from the ProDB to AnalyticDB regardless of the workload intensity. Okay, let's get started. So this is our ProDB, and this is our AnalyticDB MySQL for this demo. And we try to use this one to generate real-world traffic. First, let's set up environments to create table and insert some data. We execute this command. Okay, we can see that the table is created. Okay, let's configure DTS job. We jump into the DTS console. In the data synchronization, we can create a task. And we select the ProDB for MySQL as a source and the AnalyticDB for MySQL as a destination. And we select our cluster instance, okay, and the database account. It's password. Okay, the destination instance and the database account and the password. Okay, let's test the connectivity. Okay, the check pass, and we will try to do a schema synchronization and full data synchronization. After that, we will do the incremental data synchronization. And we select the source database. And we can see that the table created by Sysbench, and change that name to the destination, like the DB text. Okay, next. The advanced configuration is just as a template, and we jumped into the dance. Okay, we will do a pre-check to ensure the source database is supported by DTS. Okay, pre-check pass, and we do the purchase instance. And in this step, we will use pay as you go serverless, and we can select our lower DU limit and upper DU limit. We use 1 to 32 and buy and start. Okay, the instance is purchased and is on the synchronization. We will wait until the full data synchronization finish. Okay, the full data synchronization is finished and the incremental data synchronization is started. Great. We will wait till the latency show. Okay, great. The latency has shown. So, and we will start a Sysben with 200 RPS, which is quite low for DTS. Okay, great. The RPS is remain 200, and we can see the latency. Okay, the latency within 1 second, and we can see our monitor. And we can see that the RPS scale from 0 to 200. Okay. And the auto scaling, we can see that the DU scale from 1 to 2. Okay. And the latency is task latency always remain below 1 second. Okay, great. And next, we will start a system with 2000 RPS, which is 10 times before. Okay, the system launch and the RPS remain 2000. Okay, let's see the latency. The latency is all here, and latency is lower than the 1 second. And let's see the monitor. Okay, the RPS scales from the 200 to 2000, and the task latency always below 1 second. Okay, and we see the DU. The DUs from 2 to 4. Okay, great. Next, we will start a system with 15,000, which is quite high in the online system. Great. Okay, let's start the sysbench. And the RPS is stable on 15,000. Okay, great. Let's jump into the task manager. We can see the latency is always below 1 second, and the jump to the monitor. And we can see that after we scaling our RPS to 2000, always down to the 15,000, which is seven times, and the latency will jump a little bit over 8 seconds and immediately jump below 1 second. And we can see the DU. The DU scales from 4 to 32, which is the maximum in a very short time. Okay, great. And in this demo, we want to show that the RPS varies from 0 to 15,000, and which is quite high in online system. And we can see that serverless DTS always remain low task latency. Okay, so let's back to our presentation. And the demo is done. What happens when the traffic score varies? Tells resilience is mind-blowing. Let's dive deeper with our next speaker. Thank you.